call this absolute value equations and inequalities. So you remember what absolute value means, right? So like the absolute value of 3, of course, is 3. And the absolute value of -3 is 3. Right? So it's just how far a number is away from 0. You do not just change the sign. That's not true, because if you just change the sign, then that would be a -3, and it's not. It always comes out positive unless there is a negative outside the absolute value. Okay? Because it really is talking about a distance. How far is the number away from 0 on the number line? Okay? So, well, let me just ask you what would this be? That's going to be -3, because this means take the absolute value of -3, which is 3, but then that means take the opposite of it. So just to cover all our bases, what's that? That's also -3. All right, now riddle me this. Right, I have two answers. X could have been 8 or it could have been -8. Right? Yeah, so X can be 8 or -8. So this is what you need to remember when we go to solve an absolute value equation. So let's say I wanted, X plus 3 equals 10. Well, whatever is in here could equal either +10 or -10, right? Yeah, so that's what I need to do in order to solve an absolute value equation. I need to take whatever is in the absolute value and set it equal to whatever is over there, and set it equal to the opposite of what's over there. Okay, so if I give you some step-by-steps, that might be helpful. So to solve an absolute value problem, I'm not going to specify equation or inequality, because we'll just write the steps one time that will apply to both. So the first thing that you do need to do is get the absolute value by itself. So in other words, if I had something else over here like 2 plus absolute value of all this, I'd want to get the absolute value by itself. So get absolute value alone on one side. That's always going to be step one. Oftentimes it'll be done for you, like in this case it is already by itself, so I don't have to worry about that. But if you don't do that, everything's going to be wrong if there was something else there. So it's crucial that you get the absolute value alone first. Then you're going to, because whatever is in here could equal +10 or -10, I really have to solve two separate equations to get my two answers. So I'm going to rewrite the equation twice. First time, exactly as seen, but with no absolute value bars. So when I go to solve the absolute value of x plus 3 equals 10, the only way to solve it is to write two equations. One of them is just going to be x plus 3 equals 10. I just write the equation, but no absolute value bars. Because remember, whatever is in here can equal +10, so there's that equation, or whatever is in here can equal -10. So that's my second equation. So second time, exactly as shown, but no bars, and set equal to the opposite. Set equal to the opposite of the right-hand side. Let's say the other side, because it may not always be the right-hand side. And I know we're not doing an inequality right now, but we will be, and we won't want to write these steps over again. So I'm just going to add a star. If it's an inequality, you must flip the symbol over. When rewriting second time. That's super important, and a lot of people forget it, but you won't forget it because I'm going to drill it into your brain, and it'll always be there. So let's see if I can just zoom out and get back up to my equation at the same time. All right, so now I'm ready to finally do this the second time. So I'm going to write x plus 3, no bars, but now I set it equal to the opposite of this side, so negative 10. And now you just solve each equation. And there are my two answers. So step 3 is just solve each. And again, we'll deal with this when we're doing inequalities, but we might as well add it now. Solve each. Write as a correct compound inequality if original is an inequality. We'll go through that in more detail once we get to the inequalities. Okay, now we get to just practice. So now that we have all of our how-tos done, let's just rewind back to this example real quick. So I'm saying that my answers, by the way, do you remember the fancy way to write, when you have more than one solution, how you write it? Yeah. When we're dealing with inequalities, we'll do that. When it's an equality, though, so x is equal to 2, I have two answers. X is 7, and x is also negative 13. They both work. If I plug it back into the original, right, if I plug in 7, 7 plus 3 is 10, and the absolute value of 10 is 10. So 7's a good answer. Negative 13. Negative 13 plus 3 is negative 10, and the absolute value of negative 10 is 10. So both of these are answers. So when you have more than one answer, do you remember putting them in those funny brackets? Oh, well, if you ever see this, these funny brackets just mean, hey, everything that's an answer, I'm just putting in these brackets. You can do it if you just have one answer. Just people are usually lazy and they don't write it. But if I have, you know, If I ask you the question, hey, what's your siblings' names? And you have 10 siblings, you can put them in these funny brackets and just list them. Order does not matter, right? If I just ask you, hey, what are the names of your siblings? It doesn't matter what order you give them to me in. So when you see it written like this is just a listing of all my answers. It is not the ordered pairs 7, negative 13. Because those are not smooth parentheses. They're squiggles. Brackets, if you will. But when you see an answer written like this, that's just, hey, I have more than one answer, and here's the list of all the answers that work. You never seen that? Or you have seen it now that I say it? You're like, oh yeah. Never? Well, then, I guess I got to tell you this. What happens if something has no solution? Another way to write it, besides writing no solution, is to literally write x equals and just have nothing in your brackets. And it has a fancy name. It's called the Null Set. Oh, look at us getting technical here. Null Set just means that there's nothing in my set of answers. So, this just means no solution. If you ever saw that. Sometimes people also write the 0 with the slash through it. Have you seen that? Yeah. Okay. But anyway, I did have 2 answers there. 7 and negative 13, they both work. And it's just a listing. So you could have said negative 13, comma 7. Doesn't matter. It's just a list. All right, so let's get to another one. Let's say we did something like, oh, I don't know, negative 4 plus absolute value of x minus 10 equals, I don't know, 14. So if I want to solve this absolute value problem, step 1 says get the absolute value alone. It's not alone this time. So what would I have to do to get it there? I'd have to add 4 to both sides first. Absolutely. Have to. Now what would I do? Now I have to rewrite it twice because whatever is in here could equal either positive 18 or negative. So that's where I get my 2 equations from. I write x minus 10 equals 18 and x minus 10 equals what? Negative 18. And then I'm going to solve each one separately. I get 2 answers again. 28 and negative 8. I should take them back to the original and check them real quick. So 28 minus 10 is 18. Absolute value of 18 is 18. 18 and negative 4, is that 14? Yes. Try negative 8. Negative 8 minus 10 is negative 18. But the absolute value of negative 18 is positive 18, and that works too. So I could write my answer like this if I like. And since it's just a listing, it doesn't matter who goes first. If you're not good at making the brackets, it's okay. It's okay if you literally just make a squiggle, but you cannot ever, ever, ever make a nice smooth curve. Because that, for us, is like an ordered pair. That's like a spot on the coordinate plane. That's not what this means. This means just a listing of my answers. Okay? Let's try one more before we get to, we try something else. How about, all right, try that one, please. How'd you do? We got some answers? Everybody got some answers? What'd you get? Go ahead.
Negative 8 over 3 and negative 20 over 3.
Negative 8 thirds and negative 20 thirds? Yeah? Yep, what'd you get?
Negative 8 thirds and 4 thirds.
And positive 4 thirds? Any other ones? Well, let's check them real quick. If I plug in negative 8 thirds, so negative 8 thirds times 3 is negative 8. Negative 8 plus 2 is negative 6. What's the absolute value of negative 6? Is 6 plus 12 6? Okay, so that one doesn't work. Let's try negative 20 over 3. That would be negative 20. Negative 20 thirds times 3 is negative 20. Negative 20 plus 2 is negative 18. Absolute value of negative 18? 18 plus 12, is that 6?
Yes. Negative 4 thirds.
Let's try 4 thirds. So 4 thirds, that would be 4. 4 plus 2 is 6. Absolute value of 6 is 6. 6 plus 12.
No solution. Let's go.
Yeah, there's no solution here. Miss Sabia, how are we supposed to know that?
Try it.
Yeah, I mean, one thing you can always do is always check your answer. But there is a way that you can know before you do the whole problem out. And it's really when you get to the absolute value all by itself. So, what was the first thing you did? Did you minus 12 from both sides?
Yes.
Yeah. So, oh, good. Right. That gets you negative 6. Think about it. No matter what is in there, if I take the absolute value of anything, it's not going to be equal to a negative number. I'd have to have a negative on the outside is the only way that I can make it come out to be a negative, and there isn't one. So once you get right here, if you realize it, you can stop and say, there's never going to be a solution here, so I don't even have to bother keep continuing on. Now, listen. Don't get lulled into this trap, though, of always just seeing a negative number and saying, oh, no solution, I'm not going to do it. You have to, because watch, if I did, okay, so this one, no solution. So you could write x equals that null set, right? I don't care what you say, but don't tell me that there's a solution because there isn't one. But here's what I worry about. I worry about you seeing something like this. You seeing this and you're like, oh, it's equal to a negative, no solution, I can't do it.
Well, you have opposite of opposite.
Right, you have to get the absolute value by itself first. And when you do that, when you minus the 4, and then you have to get rid of that too. So that's going to turn this around, right, if I just do the first couple steps. Minus 4. So that's a negative 14. But now the absolute value still isn't alone. You'd have to divide both sides by a negative 1, right? So once you finally get the absolute value alone, you can see in this one, hey, it's equal to a positive number. This does have 2 answers. You would have to keep going. So don't just automatically look here and just say, oh, no answer. It is no answer if the absolute value is by itself and it's equal to a negative. That is no answer. So if from the get-go, if you saw a problem like this, it doesn't even matter what it looks like inside here, who cares? If it's equal to any negative number, that is no solution. And you don't have to keep going. As long as the absolute value is by itself, there's no other things with it. If it's equal to a negative number, you're done. However, don't fall into this trap either. If it's an inequality, there can still be an answer. You have to be careful. Because it could be, right? What if it was a greater than negative 1? Well, there's going to be lots of answers that come out of this that are greater than negative 1. Less than negative 1, no, that would be impossible. So you have to be careful, okay? So it's always a good idea to check your final answers. and try and be vigilant. If you notice anytime you have an absolute value alone equal to a negative, yes, you can stop because there's no solution there. Okay, ready to try some inequalities?
Yes.
Oh, good. So, the rules are pretty much the same as we've been talking about. Let's start one off where it's already by itself. So let's say it's x minus 3 is less than 12. Okay. So step 1 is already done. The absolute value is already by itself. So in step 2, that's when we rewrite this twice. So here's how it's going to look for an inequality. The first time I rewrite it, it's just like I see it there. I just don't write the absolute value bars. Okay? Just like I see it, I leave it alone, there it is. When you rewrite it the second time, though, you are going to do two things. You are going to flip that inequality symbol over and take the opposite of that number. And remember, we do that because in negative land, everything flips around. 5 is greater than 3, but in negative land, negative 5 is now less than negative 3. So there's the one thing that you need to remember with an inequality. You have to flip the symbol over, and you take the opposite of the side. Now I have two separate. I'm going to solve them separately. And then, here's where kids get stuck again. They like to just leave their answer like this and move on to the next thing. You can't. You now need to put some brain power into this and decide what type of compound inequality this is. It's either going to be an and or an or. How do you know? You have to ask yourself, are there numbers that are less than 15 that are also greater than negative 9? Are there numbers that exist that satisfy both of them? If there are, then it's an and. If there aren't, then it's an or. That's how you know. So, if there are numbers that can work for both, it's an and. If not, it's an or. So, to correctly write my final answer here, you have two options. You can write x is less than 15 and x is greater than negative 9. However, recall that ands can be written as an and sandwich, and that's preferable. You're not wrong. If you put this on your answer line on a test or a quiz, I'm not going to mark you wrong. But I can almost guarantee you when you go to take the SATs, the answer is not going to be listed like this. They're going to write it as an and sandwich. So the best way to write an and sandwich, take the smaller of your two numbers, which in this case is negative 9. And then I want the x to be greater than that, but I want it to be less than 15. So there is the correct way to write this answer as an and sandwich. And remember, only ands can be written as an and sandwich. If it's an or, you have no option but to write it in words. You can't put an or together like that. Only ands does that work for. So for me, in this Algebra 2 class, I don't care if you put this on the answer line or this on the answer line. I'd prefer you to do the and sandwich. SATs, you're going to have to do it this way, so you might as well get in the habit of doing and sandwiches. Does that make sense? Okay, let's try another one. What if we had something like, oh golly, how about Oh, we haven't done a multiplication one yet. How about -3 absolute value of x plus 5 is less than -15. I don't know. What do you suppose you do first? Divide both sides by? Now, what happens in an inequality when I divide by a negative? The sign gets flipped right now. That sign's going to get flipped, and now it's a positive 5. Now, step 1 is done. The absolute value is alone. So now I'm ready to rewrite this twice. Oh, excuse me. And then I should be able to solve from here and decide if I have an and or an or this time. Did you get what I got? Now, again, if you leave this on your answer line, you're losing points. Because you have to distinguish if it's and or. You can't just leave these two pieces dangling out there. Well, which is it? Is it an and or is it an or? In this case, it's an or. There are no numbers that are greater than 0 that are also less than -10. Right? That doesn't exist. There's not one number that fits both. So this has to be an or. So that would be an okay answer. And I think, yeah, let's just refresh our memory how to graph. So if I had to put this thing on the number line, I need two numbers, -10 and I need 0. What kind of a dot would go at -10? Open, and I would shade to the left. And then for this one, I would have an open dot at 0 and shade to the right. And then if we just rewind, I forgot to graph this one. If I have an and, do you remember what those look like graphed? -9 and a 15. What kind of dot at -9? Open. At 15 open, and then I shade where? Correct, in between them. Bigger than 9, but less than 15. That's right there. So usually, almost always your ands just look like a bar, and then your ors have them going in opposite directions. Okay, what do you think? Not too bad? All right.